Let's ponder free fall motion problem number 28. So with permission one day, you climb to the top of the bell tower and you're going to drop a water balloon from the top of the tower. Now we're given all kinds of measurements about the tower. It's 100 feet tall. There's a window on the side of it that's about 22 feet tall. And that window starts 60 feet above the ground. So let's label everything on our diagram here of the bell tower. So 100 feet right there. And then our window, the height of the window, 22 feet. And then where it is above the ground, 60 feet. And so then by simple subtraction, 100 minus 60 minus 22, this part up here would be 18 feet. And then here we are standing on top of the bell tower, getting ready to drop our balloon. Now, you're going to have to convert all of those feet into meters before we calculate anything. So 18 feet converted into meters, 5.49 meters. Okay, 22 feet converted, that's 6.71 meters. 60 feet converted, 18.29 meters. Part A. How fast is the water balloon traveling when it passes the top of the window? So again, we're going to have an interval to identify here. Here would be the top of the window. So then I'm dealing with the drop of the balloon from the roof down to the top of the window, and we want to calculate what this final velocity is here. So with this interval, we also know it's dropped. VI is equal to 0. We also know it's in free fall motion. Acceleration is a negative 9.8 meters per second squared. And we know what the delta y value is. It is going downward, so that would go in as a negative 5.49 meters. To be able to solve down for your final velocity, we have enough to use the motion equation. Vf squared is equal to Vi squared plus 2a delta y, and then plug our numbers in. So then Vf will be the square root of 0 plus 2 times a negative 9.8 times negative 5.49 meters. Solve down, we get a value of negative 10.37 meters per second. Now you may ask, well, how do we get the negative? Remember, when you take the square root of a number, it can give you a positive or a negative root. We need to choose the negative root because we know that the balloon's going to be traveling downward. So then our final answer, 10.37 meters per second down. Part B. In Part B, we want to calculate the time that it takes the water balloon to travel past the window. So then different interval here. Our interval is going to be from the top of the window to the bottom of the window. Okay, so if we think of this interval there for the window itself, at the top of the window, well, we just calculated the velocity it's traveling at the top of the window. So that's going to be VI, negative 10.37 meters per second. As it passes the window, it is still in free fall motion. Acceleration is a negative 9.8 meters per second squared. And then we also know the delta y of the window, negative 6.71 meters. And we want to calculate time. Okay, given those different things, we know enough to use the motion equation delta y equals VI delta t plus 1/2 a delta t squared, and then plug in your values. This will be negative 6.71 meters is equal to negative 10.37 meters per second times delta t plus 1/2 times a negative 9.8 meters per second squared times delta t squared. Now, we have only one unknown in this equation, and it's delta t, but we've got a delta t here, and we've got a delta t squared there. So we have variables in two different locations. How are we going to solve down when we have variables in two different locations? Well, pondering back to your algebra skills, you can either factor this into two parentheses. Given that they're decimals, it's probably not going to factor very well. So your alternative when something doesn't factor is to use the quadratic formula. Got some good math going on here. Need a little more space. Yeah, we're going to wipe that out. I need that space. Okay, so quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to take this, do a little bit of algebra on it, get everything in order, descending order. Half of negative 9.8 is negative 4.9. And then I'm going to add that to the other side. So I'll have a 4.9 t squared. I'm going to move the 10.37 t to the other side. So then it's going to be positive plus 10.37 t. And then the negative 6.71. And then equals 0. So then 4.9 would be A. 10.37 would be B. And negative 6.71 would be C. Plugging into the quadratic formula. So this is going to be negative 10.37 plus or minus the square root of 10.37 squared minus 4 times 4.9. Yeah, we're going to knock that line out. I need a little more space. Times negative 6.71 all over 2 times 4.9. Now, solve that down. When you solve that down for t, you're going to get two values, 0.52 seconds or negative 2.64 seconds. Okay? This is our time. The negative 2.64 seconds, remember we're dealing with just this portion of the fall. We're getting the time from here. Well, the math is predicting the parabolic curve up and back to the other side, and that would have been the other side. So this is our time to pass the window. Now, hopefully your heart didn't skip a beat when we pulled out the quadratic formula, but it is a math skill that you learn in algebra, and you have the skills. You need to use the skills that you have. Okay? If you're highly opposed to using the quadratic formula, there's another way to do part B. Given what you have here, you could use VI, A, and delta Y and calculate the final velocity using a different motion equation, and then take that final velocity with your givens and use VF equals VI plus A delta T to be able to solve down for that time. Well, that's two different calculations when we can have lots of fun applying the quadratic formula in one calculation. Either way is fine. Ponder physics.